class. So here's a quick demo on making Etch-a-Sketch. There's kind of a couple ways to go about this, and there's one new way if you haven't explored it yet called the key function, or the key global variable that will help you control your direction. I think right now we're familiar with key is down or key pressed from our previous assignments. So for example, it looks like this. Key code and key press kind of go together, and that causes, let me refresh this example, causes your line to move, I think. It is. I think I only had it going up and down, so let me show you again. Yeah, so this is a very, so it starts going down, and that's kind of, that is important for those working on your assignments. When you start your Tron or your Etch-a-Sketch, you should be moving in a given direction. Otherwise, the code I gave you to help you detect like game over, a collision, it won't work. It's gonna trigger game over way too early. So in this one, the one I want to go over. So then the other way you're probably familiar with is key is down. If you're using GameLab, that's the one that's most familiar. Key is down, this one. If the key is down is W, it moves a certain direction. So notice this one, I have a very tiny pink purple pixel there. And when I start moving, notice when I press the key, I move. When I press D, it moves right. When I press S, it moves down. When I press A, it moves left, and if I press, I can't press both. I think I've coded out the diagonal moving. You may not want diagonal moving to be in your code, but here's the weird thing. You want your Tron code to continue moving even though the key is not being pressed. For example, I have to keep holding down right in order for it to move. It becomes harder for you to do like two-player Tron, two-player Etch-a-Sketch, and later doing it against like a computer or something. So it's these subtleties that will make a difference in your program. I recommend that you explore this new option called key. So from scratch, I'm going to go through the process of using the key key variable, and let's get a very simple Etch-a-Sketch going. And that's what I'll hand you as your starter code. If you're a little stuck on the assignment prompt, it breaks down the instructions, but here's some more code for you to work with. So as my first thing, I added p5.js to my newly made pen. I always have a function for drawing, a function for setup. Let's have my background be black. All lights are off. Black background. And just so far, I just have a background. Let's see that's created there. Cool. I have a 100 by 100 background. Let's create a canvas. Let's make it bigger, 400 by 400 pixels, create canvas, 400 by 400, save and run, and I should see a bigger rectangle. Awesome. So the computer science world and software development has a fancy word for that. They call it incremental development. It's like pressing run or compile every line of code to make sure you're working. That way you can catch more complicated bugs. Let's say you made like 10 changes, then you run your program. You don't know which of those 10 changes causes your program to break. So after every little thing, feel free to press the run button to catch those mistakes early. And then we're going to start by drawing points. So I think it's point. Let's draw it at right in the middle, 200, 200. We want to use points because your get function just checks one pixel at a time. Let's make this white. And if I save and run, I forget if it's fill or stroke. I think it might be stroke for a point. Okay, it's very small, but it does in fact exist right there. If I use stroke weight, I think it'll be bigger. So in order to control the color of a point, you have to use the stroke function. Stroke weight, we'll make it like 50, so you can see my really big dot. Ta-da, that's a pixel. Okay, it's blown up 50 times its size. So I'm going to make a comment to myself. For the demo purposes, remember to remove this later. Just for video, lecture so you can see the pixel. Okay, so we draw a point. Now we want the point to move. So that's probably creating a variable. Let's make, let x and y be declared up here. In setup, let's make them start at 200, 200. And then down here, I should see the same exact program being run, save, run. Oh, it's so tiny. Oh, there's my stroke weight. Right, I want my stroke weight to be there. Okay, big pixel. Ooh, okay, great. Now let's get it to move. X equals x plus 1, and you're learning shortcuts for this. Y equals y plus 1. I probably don't want to do that yet. Let's just do this.
X plus equals 1.
Right. So now when I draw, ooh, right, it moves right. Great. And at this point, when I press a key, I want it to be moving left. So to figure out this new suggested thing, we're looking up the, not key pressed, I just want key. This is what I highly recommend you use for your Tron or Etch assignment. Notice this is the demo page for the key variable. So notice in their short example, they have some text displaying a background, and here's the key line. Here's the essential line. When I press A, I see A. If I press W, I see W. If I press Shift W, I see a capital W. If I let go of W, I see the word shift. It doesn't fit. If I see spacebar, press the screen, it's going to display. It refuses to display. There's a Q, there's an I, there's a J, O, E, M, A, M, I. Okay, yeah. So this thing's very useful, okay, because it determines what key was last pressed. And notice, if I last press G, it remembers my last key that was pressed. That's going to be useful for you because let's say you press W and you're moving up. You're still moving up until the user presses a different key. That's one of the benefits of using this variable. In my time playing around with this, key pressed and key is down, you have to do a lot more work in order to achieve that objective in your Tron. So let's use it. Where's my demo? Here's my demo. So now we check if key equals A, the letter A, we want to do something special. And here's a reminder of like, okay, how do I get things to move? Let's just add +2 to go here. So I save and I run. So things moving, and as soon as I press the letter A, nothing happens. Shoot. Subtle mistake. Let's try running that again. So it's moving right. I press A. Oops. I made it go right even faster. Does that make sense? A. Oop. So it went in the wrong direction. Really, I should be subtracting things. Save and run. Now I press A. Aha. It goes over itself, and then it goes to the second direction. And now we can check if key equals D. So if you're curious, like why didn't it work the first time, I had a space here, and this space lowercase a is different than just the character A. That was the error from before. My second error was doing subtraction, or doing addition instead of subtraction, so it moved to the right because now it was originally +1 in the positive x direction, but then it was +3. Now it moves to the left. And let's see if this scheme works. X equals x plus 1. Okay, now when I press D, I want this thing to go back in the right direction, positive x direction. So it's moving, it's moving, it's moving, great. And then it goes over itself, like here, and then it goes left, and now D. Oh, wait, my thing stopped. Oh, no, there it goes. Okay. So now, perhaps let me add back in my stroke to be green, R, G, and B. So then you can see what's happening with the different circles. Let's see if this makes it a bit more clear. Oh, no. White circle is 5. Right, it's a big pixel. Okay, so I can't get it to change. So my suggestion here is like, okay, but if you want to go up, down, left, and right, you have to do something funny here. Like for example, if I move originally in the right direction and then I go left, it goes overlapping and then it goes like this. Then I press D and it keeps going, it keeps going, it keeps going. You see it back over here. And if I press, let me do it faster. So there's, okay, press A. There it goes. Press D up here. Press A again. And you notice, yes, there it comes again, right? So that can get kind of annoying because the speed is not the same. Things aren't properly accounted for. I remind you back from the very beginning, if you wanted things to move in certain directions, it's going to be helpful for this kind of movement to be assigned to a variable. What do I mean by that? In the very beginning, like here, instead of just doing plus or minuses, let's make this one moving left. No, plus, yeah, D is moving right. This one's moving left. And let's make this a variable. This is your speed. This is going to be speed. This line will temporarily comment since we're adding in a new variable, speed. At the very beginning, your speed is going to be +1. You're moving to the right. And then down here, x equals x plus speed. It's a subtle change, but it will help you control your direction or your movement that much better. Speed equals -1. So if I save and run this, in the beginning, it goes like this. Then I press A, it moves to the left. And now if I press left, it moves to the right. Great. Let's make it a bit more interesting. If key equals W, we're going to make it go in the Y direction. Speed. If key equals S, we're going to make it move down. Now, since we have two kinds of directions, this is where it becomes interesting. I'm going to try to add y equals y plus speed. And there will be an unintended side effect if I move it like this. Up is -1. Remember, y grows down positively. Speed equals +1 here. This thing's going to look funny. So it moves always diagonally now. That's not what we wanted. All right, now it goes like this. So you're going to have to separate your x speed and your y speed. So let's add that in, x speed, y speed, speed E and speed x. Speed x equals this. Let's make no y direction, like this. Then up here, x, let speed y be declared. Make the right changes. Okay, so now when you press up, it goes, oh shoot, always goes diagonally. So this should be reminiscent of some of your like painting with shapes assignments or your Etch-a-Sketch. I'm getting closer and closer, however, when I press down, so right now I last pressed D, and now I want you to go up. It remembers too much. So let me save and reset. So in the very beginning, it moves right, because speed x is there. When I press S, it goes down and left. And then now I press up, it goes left and up. When I press right, it goes up and right. If I press down, it goes right and down. It's not quite what we want, because it always moves in diagonal paths after the first one. So notice, one of your big bugs that you'll accomplish, or that you'll notice is this: do you want diagonals, do you not? Now you have to separate that x and y direction. Notice in Tron, you only have right angle turns. You should only be changing in an x direction or a y direction. And one way to prevent that, the diagonals from happening, is if you're moving left and right, you should have no y speed. Here. Equals 0. That's one way you could make that part turn off. Similarly, if you're moving up and down, you should have no change in your x direction. You should have no x speed. So now if I save and run, it's originally moving in the right direction. If I press S, it goes a right angle turn down. If I press A, it makes a right angle turn left. And all those components have now been accounted for. I can only move in right angles. I can move back on myself. Yeah, that works. You may not want that to be allowed, in which case you use your logic assignments, ands, ors, and nots, not equals, to help you prevent that. So for example, if I'm moving up now, I press W and I press S. I'm kind of going over myself, and in the actual Tron game, that's either not allowed or you automatically trigger a game over. So let me save this. I'll pause that. That was a lot of talking at you, a lot of ideas mentioned. And now you have the base code for a Etch-a-Sketch assignment using key, which will save you some to pursue this assignment using key is down or key pressed, especially if you decide to use a computer.